He's going to ask you to do this again, just without notes, without a computer, without, just pen. Here's a piece of paper. You got the pencil or pen. Solve it. All right. So completing the square, the first move, one of the first moves, is to get rid of the a value. Another first move is to get rid of the c value. You could do them interchangeably. All right. I tend to want to get rid of the a value first. All right. And I've mentioned that before. It's for personal reasons. It's because I'm worried that I'm going to forget to do it. So I get it out of the way. All right. So x squared plus b over a x plus c over a is equal to 0. All right. Then we do our side work. And if it's a matter of taking like a 2, cutting it in half and squaring it, you probably don't have to write the side work. But the b value is b over a. All right. So I'm going to take that b over a. Not b over a. Well, I'm going to take the b value, cut it in half and square it, but that b value is now b over a. All right, so it's kind of weird. We're using b in 2 different contexts here, but it's how it works. So we'd say b over a over 2 squared. All right. Now, you don't have to show the intermediate steps here, but you may want to. It's up to you. That 2 is thought of as 2 over 1. So you have in the parentheses b over a divided by 2 over 1 in the parentheses squared. All right. When you divide 2 fractions, it's the same as multiplying by the reciprocal. Keep, change, flip. B over a times 1 over 2. If you multiply your fractions, b times 1 is b, a times 2 is 2a. Square the result, and you now have b squared over 4, excuse me, b squared over 4a squared. All right, and so that's what's going to get added to both sides eventually. I didn't move the c value over, but I'll do that in a sec. All right. So among these first steps, I have to get this term over, so I'll get that out of there. The more practice you got with completing the square, the more you realize that a lot of these steps aren't like locked into place. You can do them down the line a little bit as long as you do them. You got to divide out the a term. And you have to do that before you do all this work. But the c term, you can do that really at any point. All right, so I'm going to add the b squared over 4a squared to both sides. On the left-hand side, we now have a perfect square trinomial. All right. It doesn't seem like it's a very nice perfect square trinomial, but it is because the first term and the last term are both perfect squares. All right. So that was the whole point. So take the square root of the first term, take the square root of the last term, carry down the sign of the middle term. So x plus b over 2a. All right, now on the right-hand side, a little bit of a different story. I'm going to do a little bit more side work there. I'm going to extend my side work line here. Kind of partition it off. So I'm going to take the negative c over a and add to it b squared over 4a squared. when you're adding fractions, you need to have a common denominator. All right, so I'd think about, all right, that 4a squared is the one that's got the most stuff going on. I need the a to become a 4a squared. So I'm going to multiply that a. I'm going to multiply the a in that first fraction by 4a. But I can't just multiply the bottom of a fraction by something without multiplying the top also by that same something. So now I have negative 4ac over 4a squared plus b squared over 4a squared. I can put those together, tend to want to put the positive part first. All right, so that's going to be b squared minus 4ac over 4a squared. And that's going to be the right-hand side of the equation. It's not quite as simple as taking two fractions and adding them together in Desmos, but you know, it's the same idea. It's just a little bit more intense. All right. And so if I want to get x alone, I need to get rid of that power of 2. We do that by taking the square root of both sides. The left-hand side, the power of 2 and the radical cancel each other away. The right-hand side, well, we're taking the square root of a fraction. So you could take the square root of the top and the bottom separately. All right, so plus or minus on the top, the square root of b squared minus 4ac, because we can't get rid of that. That's not a perfect square, but on the bottom, 4a squared is perfect. The square root of 4 is 2. The square root of a squared is a. Then it's just a matter of subtracting off the b over 2a.
Why wouldn't the top be considered to be able to be a square root?
The b squared is, but the 4, the a, and the c aren't.
Okay.
I'm sorry, the 4 is, but the a and the c aren't. Right? They don't have powers of 2 across the board. And the minus would screw everything up anyway.
Thank you.
No problem. So I'm going to subtract off the b over 2a. And then I'm going to put it all together into one fraction because we have a common denominator. Let's see, I haven't used, no, I've used all these colors. Let me get a fresh new one in here. Oh, the light blue here. Too dark. I have a common denominator, so I could put these together and make x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And that would be the complete derivation of the quadratic formula. There's actually other derivations. There's other ways that this formula comes into existence, but this is I think the most popular one. All right. And so this is the one I'm going to ask you to do for the bonus tomorrow.